Okay, continuing in chapter 9, trig ratios, we're looking at an alternative formula for the area of a triangle. Now we're used to the formula half the base times the height, which we probably learned in year 8 or year 9 or something. We've got an alternative one which involves trig ratios. So here's our standard triangle, angles A, B and C, giving us sides little a, little b, little c. I'm going to drop a vertical here, and I'm going to call this vertical H. Now I'm going to use the formula that we learnt in year 8 or year 9 for the area of a triangle. So the area of a triangle is half the base times the height. In this particular triangle, that would be half times A times H. But we may not know this perpendicular height here. We may just have information relating to angles and sides. So I don't want this H in here. But H, this value H, I can work out using our trig ratios. So let's take this angle here. We could either do this angle here or this angle here for to help us work out H. Let's do sine C. Sine of this angle is this side over this side, the opposite, divided by the hypotenuse. In this case, it's H over B. In other words, H is B times the sine of C. So I can substitute this H for B sine C, giving me the area of the triangle is half A B sine C. So it's half of this side multiplied by this side multiplied by the sine of this angle here. Notice that the angle is always in between. It's the angle in between the two sides we know. So if we have a triangle, we know one of the angles and we know the two sides which come off that angle, then we can use this formula to work out the area of a triangle. I'm going to look at the second example in the textbook, which looks like this. In this particular one, we are given the area of the triangle. We're given the two sides. We have to find what the angle is. So let's start off with area of a triangle. Start off with our formula. Area of the triangle is half AB sine C. And this particular one, this is the angle that we're trying to find. This is C. And these two sides are A and B. It doesn't matter which way around these go, but notice that we've got the angle in between the two sides. If I had a different angle, I would have to work out one of the other angles, or indeed work out another side to help me work out the area of the triangle. So let's put our values in. I know the area of the triangle already, so if you like, this one's a little bit backwards, but I'm sure you'll all cope. Half times A times B times sine C. So let's just work some of that. That's 6 5s 30, half of that 15. So 12 equals 15 sine C. So sine of C is therefore equal to 12 over 15. Let's put that into the calculator. Make sure I'm in degrees. Shift sine 12 divided by 15 equals C equals 53.1 degrees. So setting like this, equal signs in a column, start off with the formula, substitute our values in, and then do some rearranging. Like I've said before in previous sections, some students like to rearrange the formula first and then put the values in. Absolutely fine. Either way around. Either start off with the formula, put the values in and rearrange, or start off with the formula, rearrange to get the bit we're trying to find, in this case sine C, and then put our values in. You'll get the same answer. But the question doesn't end there. If you look at the example carefully, it says that this side is the longest side. If this is the longest side, then you know this angle has to be obtuse. This is not an obtuse angle, and as we've seen previously, when we're dealing with sine, we can often get two possible answers. So I want to find what angle would give me 12/15 or 3/4 as the sine of that angle when the angle is obtuse. Okay, we can either do a little graph or cast diagram, depending on how you want to do it. So I'm going to do a quick little sine curve. That's 90. That's 1 3/4 will be here somewhere. So this value here is 53.1. Well, if that is 53.1, then the other value, which will be here, and that distance must be 53.1. So if this is 180, take away our answer, gives me 126.9. So C must be 126.9 degrees, because it tells us that this side is the longest side. So just watch out for those kind of questions, particularly when dealing with sine. Make sure you've got the correct angle. That's our primary angle. Make sure that that's actually the angle you want. If it's not the angle you want, if you want an obtuse value, then use your cast diagram or a quick sketch of the sine curve to help you work out what the other angle would be.